In this video, let's solve a question which says delete a node without knowing the head pointer. So problem statement is like that. An address of a node of linked list is given to you and you have to delete that node, but the thing is head pointer is not given to you. The address of the first node is not known to you. Only the address of a node from the linked list is given to you and you have to delete that node. Okay, so before going to the solution of a problem, first let's see how head pointer is useful to us in the linked list. So this is the linked list. As we know, this is the linked list, and suppose these are the address of the linked list, address of the each node of the linked list. So this is the address of this node, this is the address of this node, and so on. And the last node next pointer is pointing to the null. So this is a pointer variable which holds the address of the first node. So like suppose if I want to do some operation on this linked list, if I like suppose I want to traverse this linked list, so what I'm going to do, I'll define a pointer. Suppose struct node is the structure and we define a pointer of that type and we initialize it with the address of the head. So a new pointer variable will be created and it holds the address of the first node of the linked list. Now I can traverse using this pointer. So I can say while p is not equal to null, just assign the p's next value to the p, and this is how p is pointing to the 100 because p is not null. So it will hold the address of p's next. P is this one, it holds the address of this p next, which is 200. So now it will hold the address of 200, so start pointing to the this node. And now p is not null, so it will hold the address of the p's next, which is 300, and it start pointing to this node. So this is how it will traverse the linked list, and this is how we define new pointers and hold the address of the first node of the linked list, and we do the manipulation into the linked list. So this is the significance of a head pointer, and after the manipulation we also return the head only, so that main function can traverse the manipulated linked list. So this is why head pointer is very important. So suppose if address of c is given to you and you have to delete this node. So suppose pointer x with address 300, which is pointing to the c node, is given to you and you have to delete it. Then by using the head pointer, it is very easy. What you can do, you can define two pointer variables p and q. First you will point to the first node of this linked list, and then you can traverse in such a way that this q start pointing this node, which node you have to delete, and p start pointing the node before that node which has to be deleted. So p is holding a node before the node which has to be deleted, and q is pointing to the node which has to be deleted. Now what you can do, you can point the p's next, you can assign the value of q next to the p next. Fine. So you'll assign this next value to the address of this q's next. So you can write like p's next is equal to q next. So when you write this, the pointer of this node will start pointing to the next node, and this is how the breakage took place. Now the linked list will become a, b, d, and e. So when you traverse this linked list by using the head address, by using the first node address, you'll traverse a, b, d, e instead of a, b, c, d, a. This is how you delete the node of this c node. Delete this c node when head is given to you, but in the question this head is not given to you, so you have to delete without knowing the first node address of a linked list. So let's solve the question. So this is the linked list, and suppose x is given to you with the address of a node that has to be deleted. So what you can do, you can copy the data of the next address into the node of into the node that has to be deleted. So you'll copy like this. So suppose a function which says del or delete, and it holds the address x. What you can do, you can say x data, assign the x next data. So whatever be the data of next node of the x, which is d, will be copied into the x data. So d will be copied into this. Now as soon as d is copied, now what you can do, you will say that x next will hold the address of x next. So this node will start pointing to the e node, to this node, and this is how you break the link of this node. So instead of deleting this node, what you do, you copy the data of the next node to it, and then you delete the next node, then you break the link. You do not have the address of the first node, but main procedure will have the address of the first node. So if they now traverse it, so they will traverse a, b, d, and they will traverse e. So the final linked list will become a, b, d, and e. So this is how you delete the node which was c. So you did not delete it, you did not delete this node, instead you delete the next node, but the effect remains the same, that you deleted the c node. So this is the solution of delete a node without knowing the head pointer. So this method will not work if the given x node is the last node of the linked list, because if it is last node of the linked list, if it is last node of the linked list, suppose 500 is given to you, then there is no node further to copy the data. So this will not work for the last node, this method. So in the question, definitely they will give you the linked list which at least have two nodes. So this is it for this video. Thanks.